My name is Tim Today. I'm a Principal Systems Engineer for IBM Netezza. What I'd like to do this morning is take you through, if you haven't been introduced to the appliance concept and actually what an appliance is, I want to level set there. I want to talk about how the IBM Netezza platform is really unique and innovative in the appliance field today. And I want to talk about something, the quick time to value, what we call the 4 S's, which is basically simplicity, speed, scalability, and smarts. And then we'll talk a little bit at the end here about the analytics warehouse appliance. So, right, appliances make it simple. I think one of the best probably examples of an appliance today, right, is the iPod, right? It's a dedicated device, purpose-built. It's a load and go, right? If you kind of contrast that in how customers would use digital media in the past, you have a laptop or you have a desktop system, you have to load software, you have to do some configuration, so there's a lot of work behind that. So really the beauty in the appliance is something like the iPod here is it's a load and go, right? You plug it in, you play your music, very fast to download, standard interfaces, so they're very purpose-built tools. So that's exactly what the IBM Netezza concept is really all about today. We've actually been credited by Forrester and Gartner with coining the phrase data warehouse appliance. So it's purpose-built. I want to show you how this is truly an integrated offering. Standard interfaces, and what we mean by that is your tools that you use today, be it your ETL tools or your front-end reporting type tools, BI analytic tools. We don't change any of that. You don't need to change any of that. Standard OLEDB, JDBC, ODBC, SQL API interfaces. And we provide a real low cost of ownership. So we're going to see today, this morning, how we are and can prove anywhere between 10 and 100 times faster than traditional warehousing and appliances. You're going to see the simplicity, okay, in how you administer and how you deploy a Netezza appliance. We're also going to show you how we scale from a single appliance, right? We can scale all the way out to petabyte scale, and very efficiently and very cost effectively. And then we're going to talk about smart, the last of our 4 S's, and how we're able to do in-day analytics through parallel analytics accelerators, which can leverage, all your data prep, data mining, as Liam talked about earlier, your R environments, Hadoop, and so forth. So what does the traditional environment look like today, right, that we see in the complexity? Well, generally what you have is it's usually a 3-tiered environment. In my screen, there we go, it's going to build out. Really, you're talking about 3-tier environment in the traditional warehouse. You're going to select a database, put it on a server, select an operating system, and then decide, where my storage is going to go, how I'm going to manage that. So it offers some complexity right from the beginning. Most IT shops, most enterprises will at least have, the different groups handling the three different tiers. So looking at it, everybody would agree, so you can see that's illustrated here as this builds out, is that I/O is the biggest killer in any data warehouse. We've got to move the data from our storage, right, from system calls back to our server, and then through the server storage subsystems, move that, through the kernel back into our database, and we finally get a result back. So there's this constant moving of data, which adds a lot of bit of time, right, to your queries. And there's a lot of tuning. Anytime you change any one of these tiers in here, be it the database, the server, the storage level, there's always going to be some type of tuning. There's also going to be some type of regression testing because we have many different layers here. So what Netezza has done is we've kind of erased this all today. And we offer this, right, in one integrated database server, operating system, and storage with virtually no touch to low touch and any kind of maintenance or integration and deployment. So what you'll see is on the left side, that your client type of applications down below your source systems, none of those interfaces have to change. So we truly believe, right, to be able to move that all inside the Netezza appliance, that less is more. And you're going to see really on the slides further on how we really, you'll get the concept is we do not move data. We actually move the query to the data. It's a very interesting concept. So let's take a look at how we perform this feed. Let's take a look at first what the IBM Netezza appliance actually looks like. So you have actually the 3 layers. You have your disk enclosures. You have your SMP hosts. There's 2 of them, for failover and primary. Then you have what we call our snippet blades or S blades, where actual number crunching gets performed down there. So the magic sauce here, the secret sauce, if you will, and this is very unique technology using nothing more than commodity hardware. Down below you see our S blade. So we take a standard HS22 blade server, IBM blade server, and we make that up to what we call an FPGA card. And this is what it's really going to look like. So you're going to get 8 CPUs, 8 cores, on our blade center. And they're also going to see how we have what we call our Netezza Database Accelerator card, which is called an FPGA, Field Programmable Gate Array. And what that has on it is 4 dual-core processors. So what we've got here is what we call a 1-to-1-to-1. It's a very balanced, dense systems. You'll have 1 FPGA core to 1 blade core to 1 set of disk enclosures. So this is what the architecture looks like. On the outbound side, you have your applications. Again, nothing changes there. Those are standard interfaces that we use. Those interfaces communicate to what we call our hosts. Those are our 2, as I said, Linux hosts. One is primary and one is for failover purposes of secondary. They're Red Hat Linux servers, and they do, you do all your administration from there, very little administration you have to do. Your queries get compiled through there, optimized, query plans get built. And then it's shipped over the network fabric, as you see here, down to our S blades, and then to do the work. So we're going to see a little closer how that works in this next slide. So the query is issued. The first thing that happens here is we go after a slice of the data, right? So we take this using a divide and conquer strategy, and your data is put across what we call data slices across a table that run across multiple nodes. The data is compressed. So we go through an uncompression algorithm here, and that's all done at what we call the our secret sauce, our database accelerator card, the FPGA card. So we uncompress, we do our project, and we're going to select the columns that we need, apply our restrict processing, our predicates, and at this point, what happens is 95 to 98% of the extraneous data has already been removed from the query. Now, at that point, it will go up, your query will get sent up for further higher order processing SQL, such as your joins and your aggregates, which take place at the S-blade level, which is where you see the CPU core in blue. Now, an interesting thing that happens here is we do not move the data. So on the far left, you have your slice of data from the table. That data gets streamed off of that disk and is processed as fast as that data can be streamed off the disk by the FPGA cord. There is no competitor today, other vendor doing that. This is a very unique architecture. So let's take a look at simplicity. I'm not picking on Oracle here, but this easily could be a DB2 database, could be Sybase, Microsoft. So traditionally, what do you have to do? Well, you have to give a lot of thought to when you build the table. Okay, what table space am I going to put it on? How am I going to lay that data out? How am I going to index? I'm going to need index spaces, table spaces. So I've got to give a lot of thought to that. So in Netezza, we remove all that complexity, and it's simply, right, we do a create table space, and we decide how we want to distribute the data across our data slices, across our physical nodes. And that is it. There's no indexes. There's no physical tuning and administration of that. All your storage is taken care of for you. So that's our really simplicity statement here, is we go with a load and grow strategy, right? So I didn't have to do all, a JAD session to figure out, what my data model is going to look like. Most of our customers, and I would say at least 95% of them today, when they implement Netezza, they simply take whatever data model they had without any tuning, and they'll take that and they'll load it as is into the Netezza appliance. This is something we call data model agnostic. We don't care if it's a third normal form database. We don't care if it's a star schema, a snowflake. We simply go with the load and go strategy. And from that point, our customers see anywhere between 10 and 100% improvement in the performance of their queries. So let's take a look here how we scale out in terms of scale out. So you'll see, starting on your far left there, we have a 1000-3. That's a quarter rack. And then we have a 1000-6. That's a half rack. And then we have a full rack starting with the -12. So what those numbers actually mean is a 3 has 3 S blades. Again, only 2 SMP hosts. And it has 3 disk enclosures. And the same thing happens here with as we scale out to a -6 and then a full rack of 12. Now, what's interesting here is when we size, and a customer comes to us, we do not size for the capacity, the terabyte capacity. We essentially, because of the near linear scalability on these appliances, we need to know what the customer desires for query response time. So if you look down at the query times, we can almost 100% say that, okay, you want your queries to run in 30 seconds. After doing some analysis on what those queries look like, we say, all right, you'll need a -3. And some period of time goes on, and they say we have to get it down to 7.5 seconds. We can know, right, empirically, that what they'll need for scalability purposes is a -12. Now, why is this important? If you really think about the type of planning that an enterprise has to do, calculating returns on investment, time to value, it's really a good value statement in that we can scale this way at near linear scalability. So this chart here will show you, right, how we scale out. Again, what it means is predictive performance. It means predictive planning, and what it means for customers or enterprises is lower cost of ownership, total cost of ownership. So this is how we look at our configurations here. You can see the number of blades, cores, our RAM. Now, what's interesting is we look over to the far right here in our last third of our chart. We talk about user space. We talk about raw terabytes and then compression factors. Now, the compression factor, we at least see a minimum of 2x, can be up to 4x or more, and that is, it's a mileage sticker, right? Your mileage may vary. It depends on what the data looks like, repeating values, those types of things. But you'll see, Liam made a good point earlier today, you may think, like, this is too much for you for Netezza, but you'll see, like, on a 1003, 8 terabytes, but you have the potential to go up to 32 terabytes in data. So you have a lot of growth in these machines. They're very dense systems. Okay, so let's take a look at really what we offer in the smart analytics area, what we call our smarts, our last S. So traditionally what happens in that 3-tier environment that we saw earlier today, just go back one page, you typically have your 3-tier architecture, analytics grid, and what happens there, right? Really no different than happens in a traditional warehouse environment. There's a lot of moving of the data around, and especially in analytics, as data analysts are formulating, the problem definitions, doing their experiments, if you will, building their models, the predictive models. So what happens? They typically go in on a particular hypothesis. They'll grab some data. right? Move to the workstation or move it onto a grid somewhere, and it's just reiterative process over and over and over. So it takes a lot of time, right? And there's a lot of complexity involved. So this is where particular strength of Netezza plays in that we use that divide and conquer strategy. We're able to do in-database analytics and move that, take advantage of all of that power, that processing power, and put it inside the Netezza appliance. So what does that actually look like? So this is our framework that we have here. And we now partner with Revolution, our analytics, for our analytics. And that allows us to take R and run it in parallel, our code in parallel inside the Netezza appliance. We have a Hadoop NZ engine, so you can run your MapReduce Java applications. And then we also offer software development kit, which literally has hundreds and hundreds of pre-built analytics packages. And what happens is we're able to take those and parallelize those operations. So we're able also, what does that mean? What does that mean for the customer? Well, those traditional things as we saw before, moving it out to an analytic grid, if you will. So there's that constant data movement. There's a lot of complexity. There's a lot of management that has to go on. So we're taking advantage of the simplicity factor, the parallelism, and we're moving that right inside the analytics, right inside the Netezza analytics engine, and let it run there. So we don't change anything. As I talked earlier today about the standard interfaces that we use, so this is just a small smattering of tools that are out there today in the analytics enterprise. We are certified on over 300 different products that will connect up and run and have been certified to run on Netezza. So as you can see here, these are pretty much the major ones that you have there. Now, we're looking at here for just visualization and BI and analytics tools. The same can be said for any type of ETL that you may have today. If you have data stage, you have Informatica, those all are certified to run with Netezza. Let's take a look at some of the customers. We have today over 700 customers running across the different verticals, industry verticals here. This is, again, a small smattering of accounts that we have here that I've listed, but again, we have over 700. Now, what's interesting is almost 90% of our customers are willing to be references for Netezza. I think that says a lot. They have a lot of confidence in the product, and they kind of want to show the world what they're doing with it. So just a quick case study here, picked out nationwide. You can see when they brought Netezza in, the type of metric performances that they increased in Netezza. And again, what's interesting here is when we bring these Netezza appliances in, we usually stand them up within 2 days. You can actually run queries on. So the implementation time for these are very fast. I'm not sure what the full implementation here. I know they did do what they call proof of concept at Nationwide, and that was up and running within a week. Terabytes and terabytes of data, and they got some great results. So, we talk a lot about a lot of impressive numbers. We talk a lot about how fast we are, time to value. We talk a lot about simplicity, all those messages. Now, one thing that we do, it's very unique. We do, our test drive, our Netezza Test Drive. And what that is if the situation is right for you, that we seem to be the right platform, the right appliance for your particular pains that you have in the BI analytics space, we're willing to come in with your data at your site, our time and materials, and actually run a proof of concept. And that's what we do is we will actually ship, right, a properly sized Netezza appliance, bring it into your site, stand it up within a couple of days. And our POCs usually last no longer than 2 weeks because we are so fast time to value to get these appliances deployed, and get your applications running, your queries running.